New research suggests that Mars was a planet full of rivers. Analysis of data collected by NASA's Curiosity rover has provided further evidence that numerous rivers existed on the Red Planet in the ancient past. "We find evidence that Mars was probably a planet of rivers," said Professor Benjamin Cardenas of Pennsylvania State University. NASA's Curiosity rover, sent to Mars, has been wandering the wastelands of the Red Planet since 2012, drilling into rocks and passing collected samples through the advanced chemical laboratory it has on board. Its main goal is to search for evidence of the existence of ancient life. Curiosity landed in the Gale crater, south of the equator. The landing site was selected based on satellite images that showed that liquid water had probably existed there in the distant past. The photographs revealed the outlets of two channels from the crater, which researchers believe a river once flowed through. In the new study, published in the journal Geophysical Research Letters, scientists used numerical models to simulate the erosion of the Martian surface over thousands of years. They found that some of the crater formations common on the Red Planet are most likely the remains of ancient riverbeds. A recent analysis of data collected by the Curiosity rover in the Gale crater has provided further evidence for the existence of rivers on Red Plantain. Moreover, the authors of the publication indicate that they may have been more widespread than previously thought. "We find evidence that Mars was probably a river planet. We see signs of this all over the planet," admitted Professor Benjamin Cardenas from Pennsylvania State University, lead author of the publication. The first photos showing dry riverbeds and floodplains on the surface of the Red Planet were transmitted by the Mariner 9 probe in the early 1970s. Further evidence in the form of compounds formed in the presence of water was provided by various Mars rovers. Probes orbiting Mars have also identified formations created by sediments in river channels that date back billions of years. The new study is the first to use computer systems trained on images taken by Curiosity showing landforms that resemble the folds created by river flow. The simulation was also fed with three-dimensional scans of sedimentary rock layers at the bottom of the Gulf of Mexico and satellite photos of Mars. The analysis showed that the specific landforms identified from data from the Curiosity rover were created by flowing water. These forms are common in numerous Martian craters, but so far they have not been associated with eroded river deposits. We can learn a lot about Mars by better understanding how river sediments can be interpreted stratigraphically. Thinking of today's rocks as layers deposited over time, Cardenas said, "This analysis is not a snapshot of Mars history, but a record of its evolution. What we see on Mars today are the remnants of active geological history, not some landscape frozen in time," he added. This suggests that there may be undiscovered river deposits elsewhere on the planet. Most of the Martian sediments may have been produced by rivers during a period when conditions could have been favorable for life. On Earth, riverbeds are extremely important for life. Chemical and food cycles. Everything indicates that rivers on the Red Planet behaved similarly, explained Professor Cardenas. Scans of the seabed of the Gulf of Mexico made by oil companies provide a perfect comparison to Mars. In addition, a simulation of the erosion of the Martian surface showed structures that looked almost identical to the landforms observed by the Curiosity rover in the Gale crater. Our research indicates that Mars may have had many more rivers than previously thought. This offers a vision of Mars in which most of the planet once had the right conditions to support life. Cardenas explained.